Alright, let's take a look at our lesson on defining and evaluating functions. Functions and function notation is pretty important in many areas of mathematics. You'll see it on standardized tests, all kinds of places. We just need to understand what it means and how to deal with it. So the first few problems, we're going to focus on this particular graph right here, this graph of h of x, and we're going to read information off of it. So we're going to find the following function values, h of -3. So that's saying this part is the x value, so we're -1, 2, 3, and we're asked to find the y value, which would be a -1. Then again, this is the x value, and 1, 2, 3, 4, 5. We're asked to find the y value, which would be at -3. On number 2, again, we're focusing on the same graph, h of x. This is actually saying that's the y value. So they want to know where at which x values is the y value 3. So what I'm going to do is I'm going to go up to the y value of 3 and just kind of put a line at 3, at a y of 3. And we can see that there's just one place where that would be true, where h of x would equal 3, and that's at x equals 1, 2, 3, 4, -5. Okay? And then the last example, using this graph, we want to know where h of x is 1, and again that's the y value 1. So let's draw our line here at 1, see how many times it touches the graph. Let's see, we've got one here and here. So we can say that that's true at x equals 1, 2, 3, 4, x equals -4, and at x equals 2, 3. Okay, great. And so we have just looked at a couple of different ways that we could read function information off of a graph. Now let's move to a table. We're going to look for function notation off a table. So this whole row right here represents the x values, and this represents the y values, right? And we really just have distinct values. We don't know what the function g of x really looks like. We just know little bits and pieces of information. We know that when x is -4, y is 8, and so forth. So when they ask us to find g of -4, this is the x value, -4, that aligns with 8. G of 12 aligns with 0. G of 0, well, we don't have a 0. I mean, I guess if we had one, it would be slid right in there, but we don't have one. So we don't know. Maybe it exists at 0, maybe it doesn't exist at 0. We have no idea. So we cannot determine. We don't know what this is going to be. So you could put, basically not enough information. You could put that. You could put cannot determine. So you have a few, choices of what you could write here. We just don't know. And then, so let's kind of review. We've looked at graphs, we've looked at tables, now we're going to look at equations. And what they're asking us to do is, basically find h of -7, find these things. So we've got the function f and g and h. So we have 3 different functions. All right, so let's do h of -7. Again, this represents the x value. So we're going to do h of -7, we're going to plug in a -7 everywhere there's an x. We're replacing x's with -7s because that's what the function notation is asking us to do. So that would be what, -14 over -2, which would give us a 7. Okay, that's not too bad. Now this time on part B, They're wanting us to replace the x's, so we've got a couple of different x's in here, with an x squared. Okay, that's interesting. Well, we can do that. That's not a problem. All right, so g of x squared would be, so I'm going to slide the x squared in that spot where the x is. We're just going to slide it in there, and then again slide it in where the x is, and then we're going to have to clean up because that can't just really leave it like that. So let's see, x squared squared, power to power, would be x to the fourth, and then minus 4x squared plus 1. And so that would be our new function g of x squared. All right, the next one is asking us to find h of negative c. All right, h of negative c. That means we're going to put a negative c everywhere there's an x. And then we're just going to clean it up so it looks, a little bit nicer. So that would give us, what, negative 2c over negative c plus 5. Okay. Let's see. Now they want us to take the function f and insert an x minus 2 where there's an x. Okay, so right here is the x, so we just slide that in there for the x minus 2. And now it's basically, again, we just got to clean this up. So let's distribute, and then let's combine like terms. So that f of x minus 2 would be 2x minus 7. Okay, great, we're doing great. Let's keep going. The next one, they want us to take the function h and replace all the x's with a 3x. So h of 3x would be 2 times 3x all over 3x plus 5. Okay, so cleaning that up, we get 6x over 3x plus 5. Okay, we're on a roll. Our last one, f of, oh no, it's g. We want to use g of x minus 3. All right, so g of x minus 3, we're going to open up that spot where the x is and substitute or insert an x minus 3 there. Again, we're going to put an x minus 3 there. Now, hopefully you remember from your previous experience that we can't distribute the 2 over the plus. This actually means we're going to need to FOIL it. So we're going to have to do that. Now I'm going to go ahead and distribute the negative 4 into these parentheses. So that would be negative 4x plus 12 plus 1. Okay, so foiling here. So what would that give us? X squared plus 3x, so plus 6x plus 9 minus 4x plus and 12, and 1 is 13. Whew, we're almost there. Let's go ahead and distribute, or actually combine like terms. Let's say I only have 1x squared. Okay, 6x minus 4x is a positive 2x, and 9, let's see, whoops, this was a plus, silly Billy me, which means this is a minus. So this would be minus 11. Okay, so we have 9 minus 11 is a negative 2. Whew. Well, I don't know about you, but those negatives can sure get me. All right, let's go to our second page, see what we got going on here. So we've had some experience just seeing, how to deal with the function notation, doing the things it asks us to do. Now let's focus on functions themselves. And just to remember, I know you've already dealt with functions before. A function is a relation such that each x value has exactly one corresponding y value. It cannot have more than one. So when we just have a list of points, we need to look at all the x values and see if any are duplicated. Let's see, the zeros are duplicated. Okay, none of the others are. So now we look at the ones with the zeros, and they map to different y values. They are different y values, so this is not a function. Not a function. Okay, one more where we just have a list of points. Again, we're going to focus on the x's, see if any of the x's are duplicated, and they're not. They're not duplicated, so this is a function. Okay, great. Now if we have a graph, what we can do is we can use what's called the vertical line test. You probably remember that. The vertical line test is where I draw a vertical line anywhere on the graph, and if I only cross the graph once, and actually I would have to check it out, I mean all the different parts of the graph, I need to make sure that that when I draw a vertical line, it only intersects the graph one time. So this would be yes, it would be a function. Here we can see that it crosses this line, this vertical line crosses or intersects the that graph more than once, so this would not be a function. This is no. Okay, let's continue that thought over here. We've talked about function notation. We've talked about what's a function, what's not. Now let's kind of focus on domain and range, and writing domains and range in two different ways. We're going to use set notation, and then we're going to use interval notation. So let's work on set notation first. If you recall, that's with the curly brackets, you know, all x, and that little line means such that, and then you write stuff, you know, whatever the criteria is. So that's set notation. All right, that's for domain. So let's do our domain here. Our domain would be all x such that, let's see, x starts at, and it's a solid, starts at -10, and it's got a hole here, but if you look, these are other locations right there, which I don't know, maybe a 3.5 or something. They exist, so this hole really doesn't matter in terms of x values. So we're basically, x is going to be between -10 and 9. So we can say -10 less than equal to x less than equal to 9. Our range, let's see, our lowest y value is -11, all y such that -11 less than equal to y. Let's see what happens. Again, we have this strange little hole here, but if you'll look right here, this y value, whatever that is, looks like at a 2, exists. So the whole, as far as the range, it doesn't matter because we do have an actual y value at 2. It doesn't happen to be at this location, but it's over here, so it still counts. So we're basically going up to 5. Okay, let's look at our second example for set notation. Okay, so we've got the domain would be all x such that, let's see, x is basically -7 and then to forever. So what we can say is x has to be larger than or equal to -7. And our range would be all y such that, let's see, it looks like every single y, it keeps going down, keeps going up forever. So we can write it as y is an element, that weird little, almost looks like an E thing. That's a symbol that means is an element of. all real numbers, the set of real numbers, because it's in negative infinity to infinity. All right, now that's domain and range with set notation. Now our last examples have to do with domain and range on interval notation. If you recall, interval notation has like parentheses or brackets or some kind of a combo. So let's take a look. So our domain here, let's see, we go all the way to negative infinity. Again, we have this weird little, there's a hollow part here, but this one is filled in, so we're good. That's not an issue with the domain. And then we go all the way over here to, what is that, 2, 4, 6, 8, so to 9. And it includes 9, so we use that bracket. Our range, we do go all the way down to negative infinity, so let's see. Looks like we go up to negative. Now this part right here, there's no y values between -1 and 0, so we have to leave that part out. We also have to leave out -1 because there's a hole there. So we leave that part out, and then we pick back up on the other side at 0, which is included because it's solid. And then we go all the way up to, what is that, 2, 4, all the way up to 6. And 6 is included. All right, great. Our last one. These arrows right here indicate that this little guy keeps going and going and going. So our domain would be from negative infinity to infinity. Our range, now it kind of looks a little weird from what we've learned before. Perhaps we think that this arrow is going straight up. This is actually a sinusoid. See how it falls and rises and falls and rises. So the arrows are a little deceiving, to be honest. Notice how it doesn't get all the way up to 1. So what's going to happen with it, it's going to come down, and this one is going to go up. I mean, it's going to continue the pattern. So it actually, the very smallest y value is at -1. And it equals it because you know it's solid right there. And the very largest y value is 1, and it also equals it there. All right, great. Now that wraps up our lesson on, first lesson on functions.